Hi class, Mr. Morris. This is a video talking about ionic bonding. If you haven't already done this, pause the video and watch the video intro, Dogs Teaching Chemistry. It's just kind of a fun look at types of bonding with dogs. So you can look at that, and then we're going to get started with this. You notice that sodium, the sodium atom, it has 11 electrons, and what I want you to make sure that you're aware of is it has one valence electron. That's that one in the outer layer. Okay. Chlorine, on the other hand, it's got 17 protons and also 17 electrons. This is the atom of chlorine. Okay. Chlorine is in group 17. It has 17 total electrons, and that is 7 valence electrons. Again, if you would look at the electrons on the outside, you'd see that we have 1, 2, 3, 4, 5, 6, 7 valence electrons. We're going to learn a lot more about the octet rule later. We'll kind of review it, but the octet rule basically says that all of the atoms want to be like noble gases. They want to have the same number of electrons as the closest noble gas because they want to have a full valence layer. They want to have a full outer layer of electrons. And most of the time that means 8 valence electrons. Well, the easiest way for sodium to get there is by giving its electron away, which is what we see in this arrow here. Easiest way for chlorine to reach 8 valence electrons, well, right now it's got 7, so if it just got one more, it would have 8, and that's exactly what it's going to do. So you look down at the next picture. After that has happened, we have sodium with 11 protons, those are positive, and 10 electrons, those are negative. That gives us an overall positive 1 charge. And then you look at chlorine, we have 17 protons still, but we got an extra electron, so we now have 18 electrons. That means we have a negative 1 charge. And now opposites attract. So we have this ionic bond, which is just the strong attraction between a positive particle and a negative particle. This is called an ionic bond. An ionic bond is the attraction between a metal and a non-metal, usually. It's almost always between a metal and a non-metal. So if you're looking at your periodic table and you see that one of the elements in the compound is on the left of the staircase, the other one's on the right, it's going to be an ionic compound. Your metal in the ionic compound is going to lose electrons. And if it loses electrons, remember that electrons are negatively charged. So if we lose electrons, then it becomes positively charged. If you're giving away a negative, you become more positive. Just like in our example we did up here. We have fewer electrons, but the same number of protons, it becomes positive. On the other hand, if you have the same number of protons, but you have more electrons, it's going to be more negative. So the nonmetal, which gains electrons, becomes negatively charged. That's over on the right side of this table. And then we call the positive ion a cation, and the negative one an anion. The way that I remember this, there's a couple different ways, but one way to remember the cation is the positive ion is by writing it like this. The cat ion is positive because cats have paws. I know it's corny, but if it helps you remember it, then that's great. Okay. The cations are positive. Anions, I remember it's a negative ion. And if you just abbreviate negative with N, then that spells anion, a negative ion, anion. All right, the octet rule is that atoms want 8 valence electrons, usually, almost always. They want 8 valence electrons to fill their outermost s&p orbitals, the outermost layer. Metals will lose electrons, lose, give, donate electrons to follow this rule. and nonmetals will gain electrons to follow this rule. That's because nonmetals have more valence electrons and metals have fewer valence electrons. When this happens, metals become cations and nonmetals become anions. So after the change has happened, a metal is no longer an atom, it's a positive ion, a cation. After a nonmetal has gained electrons, it's no longer just a neutral atom, it's now an anion, a negative ion. Hydrogen and helium are exceptions, okay, and particularly hydrogen, that's the one we want to focus on. It doesn't have a p orbital, so it only wants 2 valence electrons to fill its outermost s orbital, not 8. But pretty much everything else, at least for now, pretty much everything else wants 8 valence electrons. We'll get into a couple more exceptions in the next unit. Alright, a chemical bond is actually a force that holds 2 atoms together. It can do this a couple different ways, and we're going to learn both of them. Right now we're focusing on ionic bonds. Chemical bonds is a force that holds 2 atoms together by one of these 2 means, either by attraction between a positive nucleus and the negative electrons, so just the attraction between the nucleus of one atom and the electrons in a close by atom. That's called covalent, and we'll get to it later. Or the attraction between the positive ion, a cation, and a negative ion, the anion. This one is what we're talking about today. This is an ionic bond. Okay, moving on down. So you'll need to review this when you're putting this in. If you're typing your notes out, if I were you, I would probably just take a picture and insert it, or maybe even print out this page and insert the picture of the whole page. But if you want to do this on the computer, there's some instructions for how to do so here. Alright, a calcium atom. Well, first we got to find it on the periodic table because I want to know the number of protons. A calcium atom has 20 protons. That's its atomic number. So if you look at calcium on the periodic table, its atomic number is 20. That's the number of protons. Well, when I say atom, then that means it's neutral. A neutral atom is going to have the same number of electrons as it does protons. But the ion is going to be different. We'll get to the ion in a second. Ion just means it's got a charge. Alright, so a neutral calcium atom will have the same number of electrons, and it has a charge of 0. So atom always is going to have a charge of 0. So our electron configuration is just the way we've learned how to write them. 1s2, 2s2, 2p6, 3s2, 3p6, and then finally 4s2, because it's in the 4th row, S block, 2nd element. To find the Lewis structure, we need to know how many valence electrons there are. You remember there's a few ways of doing this. One way is find the highest energy level. The energy levels I see are 1, 2, 2, 3, 3, and 4. 4 is my highest energy level, so circle that. How many electrons do I have in the 4th energy level? I only have 2. So I'm going to write Ca with 2 dots. And it doesn't really matter where you draw the dots, but we're going to have 2 dots. The calcium ion means it's got a charge. It's the charged particle. And the way it's going to be charged is by either gaining or losing electrons. We're going to look at the valence electrons and decide if it's easier to lose electrons or gain them to get to a full outer shell. Well, there's only 2 electrons, so to get to a full outer shell, I would have to add 6. Remember, the number we're trying to get to is 8. that would take 6 electrons to make that happen. Or I can give those 2 electrons away and just go down to the next layer. That's a whole lot easier. So that's what it's going to do. It's going to lose those 2 electrons that are in the outer layer. So we're going to get rid of those. 1s2, 2s2, 2p6, 3s2, 3p6. And the way that we show this in the Lewis dot structure is we draw it without electrons. That's just a way of showing that it gave those 2 electrons away. And then we want to put the charge on the outside. Well, how do we know the charge? We'll figure it out. I've got 20 protons, and since I lost those 2 electrons, I have 2 fewer electrons. That makes this 18. Well, my charge is the positives and the negatives combined. So if I have 20 positive and 18 negative, if I add those together, positive 20 and negative 18, I would get positive 2. So I have a plus 2 charge. Sometimes you'll see it written plus 2, sometimes you'll see it written 2 plus, and it doesn't really matter. Both of them are okay. So that's how we would write the structure for a positive ion. Let's look at chlorine. It's on the other side of the periodic table. Chlorine has 17 protons. And if we're talking about the atom, the number of protons and electrons will be the same, so I have 17 electrons. The charge is going to be 0. It's neutral, so let's write the electron configuration for chlorine. It's going to be 1s2, 2s2, 2p6, 3s2, and then it's 3p5. If you find it on the periodic table, it's element number 17. It's in the 3rd row, the p block, and it's the 5th element over in the p block, so that's 3p5. Alright, if I want to know how many valence electrons I have so that I can draw the Lewis dot structure, I need to find my highest energy level. I've got 1, 2, 2, and then I have 3 and 3. I see 3 twice. So all of the electrons in the 3rd energy level are valence electrons. I have 2 and 5. 2 plus 5 gives me 7, so I need to draw 7 dots. 1, 2, 3, 4, 5, 6, and then 7. Alright, so the goal of all these atoms is to get to 8 valence electrons. If we are forming an ion, remember that's a charged particle, and the reason that they become charged particles is because they want to get a different number of electrons than they have. So chlorine would only need to gain 1 extra electron to get 8 valence electrons, or it could lose all 7. Well, hopefully it's obvious that it's more favorable for chlorine to get 1 extra electron right there than it would be for it to lose all 7 of its valence electrons. So that's what it would do. It's still going to have 17 protons, but our complete electron configuration is going to be 1s2, 2s2, 2p6. We're not going to lose those electrons. We're actually going to add an extra one in there, 3s2, 3p6, and now if you look at our valence electrons, we have 6 plus 2, that would be 8. So I can draw Cl with 8 valence electrons, and that's what they want. They want to either have 8 valence electrons or they want to lose all of their valence electrons and fall back to the lower energy level. Nonmetals gain electrons, metals lose electrons. How many electrons did we gain? Well, we got 1 extra. We got a total of 18 electrons. That gives us a -1 charge because electrons are negative. So I'm going to put a -1 over there. Sometimes you'll see this written as just a negative sign. That's fine. Or you might see it written 1-. That's also fine. You can write it either way. Okay, now we have some examples of forming ionic compounds. This is demonstrating how ionic compounds form. You start with the Lewis dot structure for the atoms. K is in group 1, so it has only one dot. It's in group 1A, which has one valence electron, K with one dot. Then we have Cl. Cl has 7 dots because it's in group 7A. So thinking back to what we just did, potassium wants to get rid of one electron so that it can have a full outer shell. Chlorine wants to have a full outer shell too. The easiest way for it to do that is not to lose electrons, but to gain electrons, and it only needs to gain one. So these two can see that they can work together. Potassium would donate one electron to chlorine, and then after it does that, we're going to have ions, and the ions are going to attract each other. So we end up with potassium with a positive charge, and chlorine with 8 dots, because it gained that extra valence electron, and it has a negative charge. You can write it with the -1 and the +1 if you'd like, but the 1 is optional as long as it's just a charge of positive or -1. So I have one +1 and I have one -1. The charges actually cancel each other out. Our formula is just going to be KCl because I have one of each. CaF is going to be a little bit different, Ca and F. So I've got calcium, which has 2 dots. I'm going to draw them like this just to make it a little easier for us. And then fluorine is in group 17, so it has 7 dots. And again, you could find it on the periodic table to find that. It's in group 7A. It's got 7 dots. Well, calcium wants to give its electrons away, and fluorine wants to gain electrons. Calcium wants to give both of them away. Fluorine can only accept 1 because it needs to get to 8. Well, calcium could give fluorine 1 electron. Calcium still doesn't have an outer shell that's full, so it needs to give away 1 more electron. If this happens, and you still have 1 more electron to give away, what happens is there will be another fluorine atom that shows up, and calcium can give that electron to the other fluorine atom. So we end up with a calcium atom that lost 2 electrons, therefore it's got a +2 charge, and we have 2 fluorine atoms, fluorine ions, with a -1 charge. The technical term for it is fluoride ions. We're going to learn how to name them later, though. All right, and because we have 1 calcium ion and 2 fluoride ions, we're going to put Ca and then F, and the little subscript at the bottom tells me how many fluorines I have. I have 2 of them. You see that there are 2 fluorides. I've got to put a subscript of 2. Now we get to aluminum and oxygen. It's a little bit different still yet. I have aluminum, which has, it's in group 3A. It has 3 valence electrons. 1, 2, 3. Oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, 6. So I've got a total of 6 and 3. Well, aluminum has 3. It wants to give those 3 away because that's easier than gaining 5. Oxygen needs to only gain 2, so it'd be easier for it to gain 2 than to lose all 6. So aluminum is going to give one of these electrons to oxygen. And then it's going to go ahead and give another one to oxygen because oxygen needs 2 electrons. Aluminum still has 1 to give away though. So another oxygen is going to show up and take that last electron from aluminum. Okay, so we got rid of all 3 of them, but you can see that this oxygen still doesn't have 8 valence electrons. It actually wants more. So we've got to draw another aluminum. Another aluminum shows up to try to satisfy this and to get it to balance out. This electron can go to that oxygen and make it happy, give it a full outer shell. But now I've got 2 more electrons in aluminum that it needs to get rid of. So another oxygen will show up to see if it can satisfy aluminum's outer shell or its octet. And sure enough, we can have 1 electron go there, 1 electron can go there, and it's all balanced out. You end up with 2 aluminums and 3 oxygens. Now each aluminum lost 3 electrons. So that means that each aluminum is going to have a positive 3 charge. And then we have 3 oxygens. So we have oxygen with 8 valence electrons around it. That's called oxide, by the way. And each of them gained 2 electrons. So its charge is not going to be -1, but it gained 2 electrons, so it'll be -2. And there are 3 of those. So when we write this out, we just need to look at how many of each type of ion I see. I see 2 aluminum ions, so I'm going to put Al2. I see 3 oxygen or oxide ions, so I'm going to put O3, and that is our formula. The next thing we want to talk about here is some properties of ionic compounds. All of these are good things to know, but there's a couple things that are really more important than others for you to memorize. Okay. The first thing is that ionic compounds actually arrange themselves in something called a crystal lattice. You've got a picture of it right over here. This is what's known as a crystal lattice. You see the repeating pattern of positive, negative in a 3-dimensional fashion. This is to minimize the repulsive forces and maximize the attractive forces between positive and negative charges. Ionic compounds have high melting points and high boiling points. They're hard, rigid, and brittle. I especially want you to know, though, that ionic compounds don't conduct electricity as solids, but they do conduct electricity as liquids or when dissolved in water. So the best way, the very best way to test if a compound is ionic is to test its conductivity as a solid and then when it's dissolved in water. Because if it will conduct electricity when dissolved in water, but not as a solid, it's probably an ionic compound. And then the last thing that's mentioned on our bullet points is ionic compounds dissolved in water conducting electricity. The word for that is called an electrolyte. Anything that conducts electricity when dissolved in water is called an electrolyte.